So from a browser, we can connect to the board. We can then open up the appropriate notebook for the spectrum analyzer, and we can run some of the code, and then we're ready to run. We'll speed this up a little bit. You can slow down to watch the detail or refer to one of the other videos about how you get the spectrum analyzer started. We can now click the button and switch on the spectrum analyzer. The sampling frequency is set to 4.096 GHz. The FFT size defaults to 2048 points. We're going to be using rectangular FFT windowing and a decimation rate of 2. Setting the center frequency and the percentage of Nyquist visible, we can now have 0 to 2.048 GHz visible on the spectrum. So here is a summary of the spectrum analyzer parameters we currently have set. Later, we will use the Zoom FFT to increase spectral resolution. The sample rate of the spectrum analyzer is 4.096 GHz. The FFT length is 2048 points, and with a decimation rate of 2 for the Zoom FFT, this gives a spectral resolution in the plot of 1 MHz. We're only viewing the first order Nyquist band, averaging or smoothing the plot over 6 consecutive frames. A rectangular FFT window is used, and there is no graphic zoom in the first instance. The antenna is a simple telescopic and placed outside my attic window in the open air to aid reception. There are no external amplifier or gain stages, and no anti-alias or other filters used in this demo with the RF SOC 2x2 board. So we can now see the spectrum from 0 Hz or DC to half of the sampling frequency fs over 2, 2.048 GHz. The frequency resolution or FFT bin width of 1 MHz is sketched on the screen, and there are 2048 frequency bins from 0 to 2.048 GHz. On this spectrum from 0 to just above 2 GHz, we can see a number of different radio frequency bands, such as FM radio, just around 100 MHz, just above 200 MHz digital audio broadcast, and above 400 MHz we can see emergency services and business radio. Above 600 MHz we see terrestrial TV broadcast, and then a number of different mobile and cell phone bands are visible at 800 MHz, 900 MHz and 1800 MHz or 1.8 GHz. There's a number of other bands of energy visible. Some of these are other signals, and some are actually due to aliasing from the second order Nyquist zone. We'll have a look at that a little bit later on. Using purely a graphics mode, we can zoom in and out of this plot, and we can see more detail of the graphics. Of course, this is not increasing the resolution of the FFT or the spectrum analysis, and that's something we're about to do using decimation and changing the length of the Fourier transform.